David. I'm going to talk about docs accessibility for robots. I'll try to keep this concrete. So we'll talk about how to write content for AI and optimize for it. I work at Kappa AI. I'm a product specialist, and at Kappa AI we help companies build artificial intelligence assistants based on their content to their end customers or internal users. So a lot of what I do at Kappa is I help customers onboard their knowledge sources to the platform, which helps us build these agents to answer questions that are using content from the sources that you onboard, basically. So we're building a RAG system, a RAG pipeline on top of your own sources, and then you deploy that to your docs or to your community forums or wherever, or internally. 1 second. Okay, cool. I'll start off with sort of a primer and talk about the 3 different ways that LLMs answer questions. And I'll categorize these in 3 ways, but they're sort of bleeding in between, and then there might be other ways that I'm not covering here. But these are the 3 main ways I think how you get an LLM to give you an answer. So I'll start with an LLM using its training data. I'm calling this closed book answering. And this is, when ChatGPT made its first sort of boom, and since then, this has been much of the magic that people have been experiencing, right? It's just you asking a question from the LLM and it drawing on its training data to answer that question for you. And these models are trained on massive amounts of data, so this is really magical, and it just sort of works most of the time. Especially for broad stroke questions like what's the capital of France? It will have seen that data in its training many times, so it will probably answer it correctly most of the time too. So this technique, it just works, comes out of the box with these models. There's obviously limitations too that we've all realized with hallucination and cutoff dates, meaning models are trained on a data up until a specific point in time, and anything that happens after that, the model wouldn't know about. And it's not very good at providing specific information about narrow topics like your own products and detailed information about your own products necessarily. Which brings me to the second paradigm of how information or how LLMs answer questions, which is tool calling. So what we saw in the previous talk here, lots of talks about MCPs and going out and using tools to acquire data. And this has become a very popular sort of architecture, and you see it now in the applications that you use in Claude and ChatGPT, where you ask a question and sometimes it will go out to a website, fetch the information, and then come back and answer. So that's using a tool call. And the way that works is not the model itself doing the tool call. It's sort of the model. You can connect the model to tools, and then you'd have a client or an MCP host that maybe makes a tool call if you're using MCP. So what's happening? You ask a question from the model, and then the model looks at the question and looks at the tools it has available and realizes that I'll be able to answer this better if I can go out and fetch some new information. And then it goes out and fetches whatever it can. So in an example, what's the weather like in Paris right now? If it's connected to the weather API, that's a given. Like, it's going to go out and check the current temperature and so on using that tool. And this is great because this means LLMs now can access real-time computed data, and it can do different things. Like you make it write a program to analyze a CSV, data sheet or something. There are lots of things that you can do with this architecture. And things are getting better, but there are still some uncertainties here. Like, at the end of the day, it's the model sort of deciding to do the tool call and how to do the tool call. So as I said, things are getting better, but I mean, 6 months ago we were evaluating this at Kappa 2, and we saw some issues like hesitancy to use tools, inexperience with tools, and things like that. So it's maturing, but not without its limitations. Here's an example of sort of the data intake, if you will, of a system using tool calling. So you get a query, and then the LLM decides to go and use a tool to answer that question. And in the case of, let's say, a web search tool, it goes and fetches a web page, maybe parses the content of the web page, and then uses that to respond to your question. So that's one way to get external data into a system like this. Another way is RAG, or retrieval augmented generation. I'm going to say RAG from now on because I think the long form is difficult to say. But RAG is basically, rather than the model going out and autonomously fetching something using a tool call, you set up the knowledge sources that you want the model to be able to use beforehand. And then when a question comes in, you have a retrieval pipeline that, based on the query, goes and retrieves the most relevant content given the sources that you've connected the system to answer that question, and then you hand that over to the LLM for so here's the answer, please respond, sort of. And this is great because this means you control the sources that you want to use. It's faster and more reliable way to answer questions securely. It's very difficult to build a system like this to make it work well, but it's definitely a nice way to go if you want consistent answers. So those are, I guess, the main paradigms for question answering with LLMs these days. Oh yeah, a quick recap here on the data intake. So how this differs from tool calling is that you have this step, sort of preparatory step, where you decide the sources you want to add, you crawl and scrape and parse those sources, and then chunk them, which means just slicing them into smaller searchable pieces, and then they're stored. And then when you get a question, there's a quicker retrieval to fetch the relevant chunks, basically. So whether you're using tool calling or RAG, at the end of the day, what you have to do in content is I guess the same to make this as smooth of an experience as possible. At the end of the day, as AI can only use content that it knows how to extract in some way. And for us, I'm a technical writer, and I know there are a bunch of us here in the call too. For us, that means making our content in one way or another consumable by machines. And I believe that really means right now is to focus primarily on content and have sort of a content first approach. Because how these systems work is, they go out and, let's say with web crawling, right? They fetch a web page, they try to parse out the contents of that page, meaning any fancy formatting or clever layouts or JavaScript sprinkles that you've had on your dev portal. Those are at best lost in translation. At worst, they can cause some issues with parsing. So I'm getting at, like, the more value that you have in terms of just plain text content on your pages, the better these systems are going to do. Another thing is that AI really sucks at implicit context and filling in gaps and jumping to conclusions based on missing information. I've never been a proponent of things like FAQs in docs. I think it's an ugly pattern, but I've had to sort of go back on that a little bit, because FAQs is a really great way to match a query as content, basically. So the way, at least in RAG, the way you look up information is like you have a question and you try to find documentation that's similar to that question. FAQs are going to rank really highly in that. But basically, so have content. If there's a product truth that you want the AI to know about, make sure that that's covered in content, because you don't want these AIs to go out and have a guess, right? We see what happens then. And noise dilutes. So obviously, these systems are also not very good at knowing what's a better source than another one. Humans are much better skeptics at like vetting where information comes from. AI will sort of go out and retrieve and try to grasp anything it can, and then generate an answer. So some curation in terms of what gets into the system is obviously a good thing too. Lots of high quality content is better than lots of miscellaneous content. And here are some things, some more specific things to help us do this better, right? I'm going to take a closer look at each of these, but from top down, having accessible websites, meaning essentially screen reader accessibility, that type of thing, is great for these robots. Having content, as I said, content is king, really. So having that content speak for itself is also super, super good. And information architecture in general is also very helpful for establishing context for a give. So every piece of content that you have that might be fed into an AI lives inside of some context. And as technical writers, we're really good at structuring information, thinking long and hard about where should this given article live in terms of the hierarchy of the site and so on. And that context is really good to try and preserve, which means, be mindful about how you structure things. Having complementary text for visuals, and then at the end, I'll cover some more maybe future-looking things, but let's dive in. So first up, this is what sort of speaks for itself, right? But having an accessible website is great for machine readability, which for, use structured headings properly. If it's a step list, use an ordered list in HTML. This is going to help when you try to parse out content on the page and try to establish what that content means. And more importantly than just having well-structured content is avoiding malformed, sort of badly structured content, because an incorrectly placed H2 element, let's say, can be really detrimental to the meaning of content. In RAG, for example, you might chunk content of a page into based on sections, and in Markdown, you encounter an H2 element that's going to signify a new section. So and at the end of the day, just use semantic HTML and use as simple markup as possible, like tables within tables. It is another anti-pattern that I've seen sometimes. It might look good on a screen, but it's difficult for a machine to read those things. Here's a quick screen grab of what I like to read. This is lwn.net. It's just an example of, if I were only cared about parsing content, I would want every website to look something like this, where the main thing about the website is the content on the page. Sorry, 1 second. And so I'm not saying don't use CSS and don't use JavaScript or anything, but don't expect to be able to fetch information from pages like this one, this is our marketing site, and I tried to parse this myself. It didn't go too well. So, and these pages, are still needed for nice looking pages, right, with marketing content. But don't expect machines to necessarily be able to draw content from this. If you're hiding useful information in a page like this, it's a good idea to probably also have it covered elsewhere. Next one, information architecture. I covered this quickly, but it's, again, common sense. So have semantic headings. Don't sleep on URL paths if you can. So LLMs will use the structure of the URL, the address bar, a page if you're scraping web pages to try and sort of guess or estimate where this content lives and so on. So if you can, think about how pages are structured in terms of URL paths. That can also really help. Have complementary for visuals. This is again sort of a screen reader type good best practice, right? Have alt texts, figure captions or titles, and text, sort of introductory text for not only images but tables too, especially complex tables. Just have a paragraph or a sentence introducing or so you're giving an overview of a complex table is great, not only for machines but for humans too. When you're encountering something in the middle of a document, that can usually be really helpful. Cool. And then lastly, LLMs.txt. You might have heard about this initiative. I think it's a really great initiative. And it's basically a standard, proposed standard for helping make your websites more navigable, more usable by LLMs, especially in this sort of tool calling context. Here's one example on screen from one of Kappa's customers, Medusa.js. I think the idea here is you feed this text file into your LLM's context, and it's going to have a much better idea of what this product is or what this company is, whatever the LLM's text describes, and the documentation, what the contents are, what the different sections are, etc., to help it make more informed retrieval and parsing the right content. And lastly, I think this is also an emerging trend that we saw in the last talk too. And I think, just last week at least, I saw Microsoft released an MCP server for their documentation, which is, I think, a really cool use case. MCP servers, again, to sort of recap, those are the things you connect your Claudes or your ChatGPT or your agentic system or what have you to expose a tool call to the LLM. And the Microsoft Docs MCP lets you query the documentation for Microsoft. Really cool use case, and I'm looking forward to seeing what else comes out in this space. So, I mean, the key takeaways for making your content AI ready is, use semantic HTML, structure your content properly, make sure content is your number one priority. And plain text is at the end of the day what the machine sees. So a little trick that I like to use sometimes is to go on a page. If I'm not sure how that page might parse, for example, I can go in and I can use my browser's reading view or whatever of a page to sort of grok, okay, what does this look like if I just strip out all the styles? Filling in the gaps, making content explicit rather than implicit. Yeah, well, we've gone over this, but yeah, it's basically at the end of the day, so better robot accessibility, right, is better human accessibility too. And these systems do super well with unstructured content. These things that I'm talking about here is sort of just cherry on top and optimization. But yeah, that's all I had for today. So thank you very much.